Buckle up and get ready to challenge your understanding of time. Scientists say if something can't be touched or seen under a microscope, it's like it doesn't exist. But what about time? Is it just an illusion, or does it have its own tiny building blocks? Let's dive into the mind-blowing world where physics meets mystery and uncover the secret components that make time tick. Get ready for a fascinating concept that will make time seem more accessible than ever. Meet the time crystal. But don't worry, it's not some high-tech gadget. In fact, anyone can create one, even a small child. So, let's explore what exactly a time crystal is and how it connects with something as simple as watching a video together with your friend from different distances. Now, let's dive deeper into what makes this time crystal concept tick. When each frame from our video reaches your eyes, it takes a whopping 3.34 billionths of a second. Or put another way, 3.34 times 10 to the power of -9 seconds. Meanwhile, for your friend who's further away, that same frame takes about twice as long to reach their eyes, at 6.67 billionths of a second, or 67 times 10 to the power of -9 seconds. This difference is all due to how quickly light moves through space at an incredible speed, 983,570,1,050 feet per second, or 299,792,458 meters per second. Basically, the fastest signal can travel in our universe. And that got me thinking, even without any external cues, like sounds or lights, we still have this internal sense of time passing. Close your eyes for a few seconds and see if you can feel it, the seconds ticking by as they always do. Now let's imagine a world where time starts moving slower than even the speediest signal in the universe. That's right, slower than light. It'd be as if our lives were just a super slow-motion video with laggy internet. Everything around you would come to a near standstill, like in those creepy horror films. At first, it might seem weird just looking at things, and then, before you even turn your head, everything behind you would start to freeze up too. The light from all that motion taking its sweet time to reach your eyes. And if you somehow manage to hit the speed of light yourself, well, get ready for a real mind bender. Time would essentially stop for you altogether. But wait, things get even wilder. According to Einstein's groundbreaking general theory of relativity, if you somehow broke through the speed of light barrier, time would do something that defies our understanding. It'd start moving backwards for you. Cause and effect rules would go out the window, and you'd see effects happening before their causes. Imagine a stone flying up towards your head, but someone hadn't even thrown it yet. As strange as this sounds, luckily we don't have to worry about this in reality, since time travels just slightly faster than light, which means we never get stuck with a frozen picture show. If things were different, though, the consequences would be mind-blowing. Light would reach every point in the universe instantly, and you could see all moments across time at once, past, present, and future, all mixed together in a cosmic snapshot. But here's the catch. Since time actually moves slightly ahead of light, we can't pin down its tiny particles, even if we know their exact location in space. You see, objects appear to us for just a fleeting moment, maybe millions of a second, before their photons hit our retinas and we perceive them. That means no matter how precise our tracking is, the time particle will vanish before its light signals can reach us, or it'll be too late, and we'll only catch up to it after the fact. In this bizarre scenario, the particle of time would essentially teleport away, leaving behind a trail of light that's still rushing towards us. And get this, when we finally do see it, the image of the time particle would seem to split like a ghostly double exposure, as if we're witnessing its arrival from two different times at once. Now, imagine when we do manage to spot this elusive time particle, its image would seem to shatter into two, like a rip in fabric. One part appears directly ahead, as if following the path of the speeding particle, while another part slides in from the opposite direction, forming a ghostly trail that blurs and fades as it moves away. These mind-bending particles are called tachyons, and they're thought to have something truly strange: negative mass, which defies our understanding of how mass behaves. You see, the more mass an object has, the harder it is to speed it up, right? But with tachyons, it's like the opposite. The heavier you try to make them, the faster they'd accelerate, as if they're repelled by normal physics. If we were somehow able to push ourselves towards light speed in space, what would happen? we'd find that our mass becomes a major roadblock. The more massive we are, the slower we'd accelerate, like hitting a cosmic brake pedal. But here's where things get really wild. Photons, the tiny particles that make up light, are actually massless, which is why light can zip through space at incredible speeds. Now, if we flip the script and imagine particles with negative mass like tachyons, they wouldn't slow down like normal objects would. Instead, they'd keep accelerating forever. This mind-bending property could be the reason we experience time in a linear fashion. It's as if our reality is being pulled along by these speedsters. But remember, all this is still purely theoretical, leaving the door wide open for some seriously cool possibilities. Take, for instance, the tachyon anti-telephone concept dreamed up by Gregory Benford back in 1970. This hypothetical device would supposedly let us send messages to the past using these speedy particles. Just imagine being able to communicate with our ancestors or even change the course of history. It may sound like science fiction, but who knows what breakthroughs could come from exploring these radical ideas. Just think about it. With this theoretical tachyon anti-telephone, you could essentially call yourself from the future to sign up for Riddle a few years ago. But before we get too excited, let's bring things back down to Earth. Detecting actual time particles is an almost impossible task in reality. It's like trying to find a needle in a haystack, or in this case, a single grain of sand on a vast beach. However, that's where crystals of time come into play. These aren't the literal building blocks of time, but rather objects that can help us visualize and grasp our understanding of time as a physical dimension. You might have heard about a fascinating concept called time crystals. And it all started back in 2012 when Frank Wilczek from MIT and Alfred Shapiro from the University of Kentucky proposed this idea. Now, don't get your hopes up for sparkling gemstones. In physics, crystals aren't about glittering objects at all, but rather a fundamental structure that underpins every solid form of matter. Think of it like a blueprint for how atoms arrange themselves into a precise pattern. This is what gives substances like ice its rigidity, as opposed to remaining a liquid or gas. To understand time crystals better, imagine taking a piece of ice and placing it in an environment so pristine, a complete vacuum, that it's completely still and disconnected from the world around it. Here's where things get really cool, or should I say really still. In this vacuum world, our ice crystal just freezes in place, no longer melting or growing as it would with nearby water molecules. But what if we told you Wilczek thinks there's more to the story? He says that while atoms might stay put in the first 3 dimensions of space, they're actually oscillating, or moving back and forth, in the 4th dimension time. This means these special crystals aren't just static, but are instead dancing through time with a consistent beat. That's what makes them time crystals. But fast forward to 2014, and 2 physicists from Japan, Haruki Watanabe and Masaki Oshikawa, threw some cold water on the idea. They claimed that time crystals might be more of a theoretical fantasy than a real-world possibility. Let's dive deeper into why some scientists thought time crystals might not be possible. It all comes down to how those atoms in the crystal interact with each other. To create a time crystal, every single atom needs to be connected to its neighbors and to all the other atoms. But here's the catch: as atoms get farther apart, their connection gets weaker. So could time crystals really exist? It seemed unlikely until some Russian physicists from ETMO University in St. Petersburg decided to give it a shot. Led by Valery Kozin, they took a bunch of atoms, chilled them to almost absolute zero, the coldest temperature possible, and then did something clever every nanosecond. They'd flip the magnetic fields around those atoms. This constant nudge helped keep the atoms connected, setting the stage for what could be the first ever time crystal experiment. So, what's the deal with time crystals? Can they actually exist? Well, when you think about it, natural processes don't often flip magnetic poles that quickly. So maybe these crystals are more of an idea than a reality. But there's a twist. Quantum entanglement comes into play here. This mind-blowing phenomenon lets particles connect and share secrets with each other, no matter the distance. Imagine being linked to someone across millions of light years. It sounds crazy, but that's basically what entanglement does. And get this, if quantum entangled atoms are part of a crystal lattice, they could theoretically maintain their connection even when far apart. The challenge: getting all those atoms in sync with each other through entanglement. A super tough task to achieve in a lab setting. So, scientists have found ways to try and force these particles into that entangled state through a super precise laser targeting process N. But even with this high-tech approach, there are no guarantees of success. However, in a surprising turn of events, researchers Sean E. Barrett and his team at Yale University discovered something fascinating: kids can actually create time crystals all on their own. That's right, it seems that many children around the world have been unintentionally making these crystals as they play with homemade chemistry sets gone, which contain a special substance called monoammonium phosphate. Who knew being a little scientist could be so cool? Now, here's where things get really cool. Scientists have found that time crystals can naturally occur in something you might find in your local toy store. Monoammonium phosphate, the magic ingredient in some kids' chemistry sets. Imagine a future where these homemade crystals replace our regular watches, and they'd never lose or gain a single second. No more worrying about timekeeping even if all clocks in the universe stopped working at once. Thanks for joining us on this mind-blowing journey. Don't forget to hit that subscribe